Okay, so in 1.7, we're actually getting into inequalities. Obviously, when we're talking about inequalities, we're talking about using these symbols of less than, greater than, less than, equal to, and greater than, equal to. For the most part, when you're working with intervals or inequalities, you are dealing with pretty much the same process as though you were solving an equation, with just a couple exceptions there, and we'll talk about that here in a minute. With solving an equation, you usually get one answer or a bunch of answers, like 2 answers, 4 answers, depending on the polynomial. But when you solve inequalities, you don't get one single number for your x value. You're actually going to get a range of numbers. So we can say it can be anything between 0 and 5. It can be anything greater than 3. It can be anything less than 3. So you actually end up writing them either as a graph. You can put them in interval notation, or you can also write them as inequalities. So that's kind of what the interval notation is talking about, is instead of leaving our answers as an inequality, how can we put it in this form? So the idea is, if you have x greater than 3, then we are saying the value of x can be anything as long as that number is larger than 3, right? So that means if you're talking in terms of number line, you're going all the way to positive infinity. So x can be anything. Now this one here is a strictly greater than inequality, right? Which means 3 itself cannot be a solution. But anything beyond 3, so even something like 3.00000000001 can be part of my solution set, but 3 itself cannot be. And of course, nothing smaller than 3 can be included in that. So depending on what textbook you are looking at, some of them like to use this open circle when they're doing the number line, but we're actually going to be using parentheses. So when you're not including a number, you use parentheses. When you are including a number, we use brackets. So here you can see we are saying x is less than or equal to 4. So when we use less than and equal to, that means you're also using the number as part of your solution set. So this guy here is saying 4 itself is going to work, but then anything smaller than 4 will also work till you get to negative infinity, which you really cannot get to negative infinity. So you will notice we use open circle for strictly less than or greater than. We use a closed circle when you're including the number. Parentheses for not including, brackets for including. So that's how we can tell the difference. So if you look at your interval notations here, I have parentheses 3 going all the way to infinity, and then since I'm going on the negative infinity side, I put my smaller number first. So that's negative infinity to 4, including the 4. We always write the smaller number first. 3 is smaller than infinity. Negative infinity is smaller than 4, and then the parentheses or the bracket tells us if we're including our endpoints or not. Infinity and negative infinity are not real numbers, right? Infinity, the symbol just tells me my number is going to keep growing as it moves forward. Negative infinity tells me it's getting smaller and smaller. So since technically infinity and negative infinity are not numbers, we do not put brackets on them. We always leave parentheses. Even if you're including all your answers, you still put parentheses on infinity. And negative infinity, we never, ever put brackets on them. Okay, so it's showing you just different types of examples of how to write the interval notation. This is what we saw. If x is greater than 3, in our example, so that means you're going from 3 to infinity, in this case, a to infinity, and your graph is going to look like this. If you're going towards the negative side, we're saying x is less than a. That means you're going from negative infinity to a, and of course your graph is going to be heading to the left-hand side. This is just showing you what happens if I use less than, equal to, and greater than equal to. So you can see I am now switching to brackets in these two options. If for any set you end up getting all real numbers as your solution, which means you're going all the way from negative to positive infinity, you're basically using the whole number line, right? You shade the entire number line. So they're asking us to write the inequality based on this solution set. So if it helps, you can start out by drawing a number line, hopefully straighter than mine. And where would I be going? I know 5 is my cutoff point. What direction am I going? We're going to the left. Since we're going to the left, let's shade the left-hand side of our line. And they're asking us to write inequality, which means we're writing it something like that. What would my inequality look like? I would still use x for my variable. Is it less than, greater than, less than, equal to, greater than, equal to? Less than, equal to? Yeah, less than, equal to, because we are saying 5 and everything less than 5. It's got to be the less than symbol. Since I have a bracket on the 5, that tells me I need to include my equal to sign with the inequality. So it's the bracket that brings in the inequality symbol, and since it's 5 and number smaller than 5, we're using the less than. So this is the answer we're looking for. All right, now how do we solve these inequalities? So instead of linear equations, we're looking at linear inequalities. For the most part, like I said, it's going to be the same as solving an equation with what 2 exceptions? Does anybody remember?
It's not just one answer.
Sorry?
It's not just one answer.
It's not one answer. Yeah, you're not going to get an answer. We're going to get something as an interval. What else? Do you remember? Robert?
Isn't it if you divide by a negative, the sign has to flip?
And multiply also. So if you multiply both sides of your inequality by a negative number, the direction of your inequality symbol has to change. Same thing with division. If you divide both sides of your inequality by a negative number, the direction of your inequality symbol has to change. Addition, subtraction, nothing happens, everything stays the same. Multiply by a positive number, nothing happens. Divide by a positive number, nothing happens. It's only when you multiply or divide by a negative number, the inequality symbol has to change directions. So let's see what happens here with example 2. Alrighty, so what do you guys think? Where should we begin with example 2? -2, inside the parentheses, we've got 3x minus 2 greater than equal to 4 minus x. Yes, you want to start with distribution. So distribute that number inside the parentheses, which will give us +4, yeah. So -2 times 3x will give us -6x. -2 and -2 will become +4, greater than equal to 4 minus x. Okay, what do we want to do next? If this were an equation, what would we do? Samantha?
I was gonna say you gotta get like the 4 on one side, and like you gotta group them like the things of equal sign first.
Yeah, so get your basically x's on one side, get your constant terms on one side. So do we want to move the 6x or the single x? Do I move the 6x? If you move the 6x, you will avoid working with negatives. If you move the x, you will have a negative, which is still okay. I have a 4 left behind, greater than equal to 4, and what is -x plus 6x? Yeah, very good, +5x. Since I moved the x, let's go ahead and subtract this 4. Move it to the left-hand side, and 4 minus 4. What's our x? Yeah, so we divide both sides by 5. 0 divided by 5 is 0. So you've got 0 greater than or equal to x. So if you want to put your x on the left-hand side, it's going to be x. You can see the pointy end of our inequality symbol is towards the x. So you're going to write it this way. Equals or less than or equal to 0. So on a number line, what direction am I going in? I'm going left because we're saying x is less than 0. What? Okay, can you do it now? Okay, and what symbol will I have on my 0 itself? Bracket. Since we're saying equal to, you're actually going to put brackets on your number. As an interval notation, what will I have?
0 to -.
Okay, Raylan, you want to think about that?
Well, negative infinity with a parenthesis and then comma 0 with a bracket.
Yeah, so since we are going towards negative infinity, if it helps, we can put the negative infinity there. You're going from negative infinity to 0, right? Because we're not using anything on the right-hand side of 0. Everything is going to the left. So you put the smaller number first, which is negative infinity, 0. We always, always, always put parentheses on infinities or negative infinity. And here, since we're including 0, you use brackets. And that's the reason why I like that they're using brackets with the graph, because the bracket tells me I should also have a bracket on my interval notation. So it carries forward with that. Question on this example here. So this was just to get us into solving inequalities, but we're really looking at these compound inequalities. And compound inequalities, depending on what kind of inequality you have, you can have solution sets where you can be sandwiched between two numbers, right? So either including the endpoints or not including the endpoints. Or you can also have something like these where you have half open and half closed. So one side is included, but the other side is not included. So it will really just depend on what your compound inequalities look like. Now here's the interesting part. You will notice in your examples, you have compound inequalities that are either using the word and or using the word or. The word and actually represents the intersection of a set. So that actually means whatever answer I get from the left inequality and whatever answer I get from the right inequality, the common solution set will only be where I have common answers. The intersection for the two sets is happening. If you think about it, when we talk about intersection, if this is the solution set from my left-hand side, and if this is the solution set from my right-hand side, then in the and inequality, only what's common between the two sets can be used as our solution set. But when you are talking about an or inequality, which is coming from union of sets, does anybody know what union of sets means?
Everything.
It's all of them, yeah. So you take what's common, you take what's not common, basically put everything in the soup and make, a combined whatever. So union basically means bring what's common, bring what's not common, let's put everybody together. Intersection says no. Only what this set has and that set has, what is common, that's the only answer we can use. And that's kind of what this description is talking about. These are just your notations for the intersection and the union. So let's go ahead and see how we can solve these inequalities. They will be very similar to what we did in this example too, but we'll do it for both sides. So you've got 5 greater than 8 minus x and 1 plus 0.5x less than 4. So on the left hand side, what should I do?
Add the x.
Add the x.
You avoid negative.
If you want to avoid the negative, okay? You're gonna make me do 2 extra steps. Alrighty, we're adding the x, which will give us what? X plus 5 greater than 8. Subtract the 5. Which will give us x is greater than 3. Alright, tell me what will our interval notation look like with this guy. So here's my number line. We're going from negative to positive infinity. Somewhere over here is the 3. Where do we shade? The right, yeah, very good. So this is where we're including it, and what's going to be on the 3 itself? Parentheses or brackets? Parentheses, because this is just a greater than, there is no equal to sign on that 3, right? It's just greater than, that's why it's parentheses. If you had greater than equal to, we would have done a bracket. What will that interval notation look like?
Open parentheses 3, comma, period. I mean,
Infinity?
and then open.
Yeah, so since we're going to the right hand side, that means 3 is my smallest number. I'm going to infinity. So that's going from 3 to infinity, and both sides will take parentheses since we're not including that 3. All right, so this was the left hand side of our and inequality. Now let's see what's happening on the right hand side. So where can we start with this guy? Where would we start? Yeah, subtract the 1, bring it over to the right hand side, you will get 0.5x less than 3, and then what do we do? Okay, so if I divide 3 by 0.5, what am I going to get?
6.
Yes. Oh. Because 3 divided by a half will give you 6. X is less than 6. What will that graph and interval notation look like? And right now we're just doing this for individual sides. We still have to figure out what the common answer will be. So let's say 6 will be somewhere here. This is going on the positive side. This is going to the negative side. What part do we shade? The left, yeah, because it's x less than, which means we are going to the left. And what kind of symbol do I put on my 6? Parentheses. Because you're not including this 6, which means your interval notation will be
Parentheses, negative infinity, 6.
very good. Parentheses, negative infinity to 6, and again, parentheses on that, right? Now remember, these are 2 individual sides. We still have to figure out, since this is an and inequality, we can only use the intersection of the 2 sets. So let's see if we can figure out what this intersection is. Let's do our number line for both of them. This is negative, this is positive. We have 3 as the cutoff point here. We have 6 as the cutoff point here. This guy here is going 3 to positive infinity, right? Which means we are going to the right hand side with this one. With the other inequality, you have x is less than 6, which means we were going towards negative infinity. We're going this side. So where is the common ground basically between the 2 inequalities?
anything greater than 3 but less than 6.
Yeah. So anything greater than 3 but less than 6. So that actually means the only place where these two guys are meeting is right here. That's where I will have the intersection. And remember, we had parentheses on 3, we had parentheses on 6. So what will our interval notation look like for the compound inequality?
Parentheses 3, comma 6 parentheses.
Parentheses 3, comma 6 parentheses. Yeah, very good. Anything between 3 and 6, but not including the numbers 3 and 6 itself. Does that make sense? Anything that did not make sense or you have any questions about? What happens with number 4? Well, pretty much the same thing happens with number 4 with the exception that you get to keep everything that's common, everything that's not common, since this is an or inequality. Alrighty, so let's see. We've got, I guess, add x here, if you want to keep it positive. And since I'm moving my x, let's go ahead and subtract our 7, move it to the left-hand side. So on the right-hand side, I've got x plus x, which will make it 2x. Left-hand side, I've got negative 7 plus 1, so negative 6, right? Okay, we're dividing to get our x by itself, so divide by 2. And that's a positive 2, so we don't have anything to worry about. You will end up getting negative 3. If you want to rewrite this, the open mouth is towards the x. So we're saying x is greater than negative 3. Negative 3 will be here, infinity, negative infinity. We're saying greater than, so what direction are we going? To the right? And what am I putting on my negative 3? Parentheses. Is that parentheses?
Yeah.
Yeah, okay. Interval notation will be
Parentheses -3, infinity.
Yeah, very nice. Parentheses, negative 3, comma, infinity. One more parentheses, and that brings us back to the other side. I guess I'm going to start by subtracting my x, bring it to the left, and add the, no, subtract the 3. Move it to the right. So we'll have 4x minus x, which is 3x greater than negative 3. And what will that give us? Very good. X will be greater than negative 1. So let's see, negative 1, negative and positive. What direction are we going in?
Right.
To the right. Very good. And what symbol on negative 1 itself? Parentheses. In interval notation, that will look like,
-1, comma, infinity, parentheses on both.
yeah, negative 1 to infinity, put parentheses on both. So these were individual sides. Now for the or inequality, for the compound inequality, let's see, we're going from -3, -1. -3 is also going to infinity. -1 is also going to infinity. So if this was an and inequality, then we would have only considered the part where both of them are, right? But since this is an or inequality, this is saying take what's common, take what's not common, put them all together. So actually you will start from -3. And then of course we had parentheses on both of them. Since we're starting with everything that's not common, you will actually start from here, go all the way to infinity. And of course, we're still not including 3. So can you tell me what the interval notation for this guy will look like? You think?
Parentheses -3.
Yeah, so since we're starting at -3 and we're going all the way to infinity, it's actually going to end up looking like this one here because that included our other inequality also. Okay. Number 5 is actually a and inequality. This is actually a different way of writing an and inequality. Because the way it is set up, you will actually get a number which will be sandwiched between two numbers. So you've got -2 less than equal to 4 minus 6x less than 22. So the goal here is in the middle portion, you want to isolate the x. You want to get that x by itself because it's going to end up looking something like this. And in this case, since you had less than equal to, so we need to get the x by itself and you'll have some numbers on either side of that. So that means where should I begin?
Subtract 4 from both sides.
Well, all 3 sides, yeah. So from here, and from here. So what will our left-hand side become? -2 minus 4?
-6.
-6. In the middle, of course, our 4's cancel out, leaving behind -6x less than 22 minus 4? 18. Now what do I gotta do?
Divide by -6.
Finally, divide by a negative number so we can talk about this. -6, -6, -6. We are dividing by a negative number, which means the directions of our inequalities have to change because we're dividing by a negative number. -6 divided by -6?
1.
Yep, +1, but now it's going to be greater than equal to. Of course, we are now left behind with just x in the middle. Greater than 18 divided by -6?
3. Or -3.
Negative. And you can see we kind of got our sandwich here. So if I want to put this in order, I'm going to bring my -3 here. I'm going to bring my 1 here. The open mouth is towards x. The open mouth is towards 1. Bless you. So what will this look like on a number line? I've got -3. I've got 1. We're saying x will be between these two numbers, right? So obviously our shaded portion is going to be right in here. Now what symbol do I put on -3?
It's parentheses.
Parentheses, because this is a strictly less than symbol. On 1?
Bracket.
Bracket, because I have less than and equal to, so that will become a bracket. So what's the interval notation?
Parentheses -3, comma 1 bracket.
Parentheses, -3, comma 1 with the bracket. Okay. Questions? All right, I actually do want to look at a couple of these absolute value examples. absolute values will mimic what we did with the equations, but it's going to look slightly different from an equation. Okay, so just to help you out, with absolute values, if it is a less than symbol, so a less than symbol means you are going to have an and compound inequality. If it is a greater than symbol, that means you are going to have an or inequality. So you can see here, when it is greater than equal to, we have or. When it's less than equal to, it's and, but you can actually write it as a three-part inequality if you want. So let's take a look at these examples here. So you can either set this guy up as 5 minus 4x less than equal to 1, and 5 minus 4x greater than equal to negative 1. So the first one is going to be straightforward, like you're just getting rid of your absolute value symbols. But the right-hand side, you change the direction of your inequality and you change the sign to make it a negative 1. So this is the difference. I have changed my inequality symbol and I have made this a negative number. Or if you want to set it up as a three-part inequality, you will have 5 minus 4x in the middle. We have less than equal to 1, and you will actually still use less than equal to, but if you look at it from the perspective of this, you can see my open mouth is now facing the 5 minus 4x, and you can do your negative 1 on that side. They are the exact same thing, whichever one makes sense for you, and you will see both of these examples on your exam, one with the and setup, one with the or setup. So you kind of have to recognize if it's less than equal to, it's going to be an and. So I can write it as a three-part inequality. If it's greater than, it's going to be the or. So this guy will actually end up giving you, if I subtract that 5 on all three sides, I've got negative 6 here, negative 4x in the middle, and what's that? Negative 4 on the right-hand side. You are again dividing everything by negative 4. Since we're dividing everything by negative 4, this direction will change. On the inequalities again, I will have positive 3/2 greater than equal to x greater than equal to 1. Just putting it in the order facing the other way, you will have 1 less than equal to x less than equal to 3/2. That will of course be between 1 and 1.5. What symbols would I put on my endpoints? Which one? Brackets. Alrighty, which means your interval notation will go from 1 to 3/2.
And we're only doing brackets because up there it says greater and equal.
Equal
Okay,
to.
on
Yeah.
both sides.
Both sides, yeah. And that can happen even with this guy here, that greater than equal to will stay throughout the problem. Now the setup for number 7 is going to be or, since that's a greater than equal to. So this one we do have to set it up as 2 separate ones because with or there's no combining them. So this guy will, same as before, exact same setup without the absolute value symbol, 3 minus 2x greater than equal to 5, or minus 2x. Change the direction of your inequality. Put a negative sign on the 5. So in the second setup, again, inequality symbol will change and you will get a negative on the number. So start by subtracting 3. 5 minus 3 will give you 2. Now here we are dividing by a negative number, negative 2, which means our inequality has to change directions. Pretty much the same process here. I would start by subtracting 3. But now, since I had negative 5, that will become negative 8. Again, we're dividing by a negative number to change the direction of your inequality. Four. I've got negative 1. I've got positive 4. This side is telling me x is less than negative 1. So what direction am I going in? To the left. What am I putting on my negative 1?
Bracket.
Bracket. And this guy is actually going to negative infinity. This is going to positive. 4 is saying greater than or equal to 4, which means I am going in this direction, and that equal to, again, tells me include the 4. We have not seen an example like this. This is the first one because these are two separate pieces, right? One of them is going to the left, the other one is going to the right. Any ideas of what this interval notation will look like?
Open bracket -8 and then -1.
Negative infinity.
-infinity, and then -1 bracket, and then the u, and then bracket 4, and then infinity.
Very good. You should be very proud of yourself. Yeah, so you're going from negative infinity, and I can see where that 8 came from. That's not supposed to be an 8. I just don't write well. Okay. So that
And it's
should,
a parentheses because you're not including negative.
we never include infinities.
Yeah.
Yeah. So that's why that guy will stay at parentheses no matter what. Then we're going to -1, but we are including it. So this is representing this portion, right? Then we're starting at 4, and we're including 4, so bracket on it, and we're going all the way to infinity. And just like Jose said, since these are two separate pieces, this is an OR inequality. We actually use our union symbol to say that we're putting the two halves together. We're including them together. So since they are two separate pieces, we needed to do that. Now, very quickly, I actually just want to talk about the last two examples, and there's not much solving in these. It's more logic, critical thinking. Absolute value. Can absolute value be a negative number? For both of these? No, it cannot. However, can my distance be greater than -5? Okay, let me ask that one more time. This distance here, absolute value of 3x minus 7, can my distance be greater than -5? No, I'm not trying to confuse you. Distance can be 0 if you haven't moved. Distance can be positive. So is 0 and any positive number greater than -5? Yes. So this is actually the instance where we will get this, because no matter what value you put for x, when I solve this, I'm always going to get either a 0 as my answer or a positive number as my answer. So that means on a number line, we're basically saying you can use anything from negative to positive infinity, and it's going to satisfy our equation. In that same logic, come on, buddy. Can my distance be smaller than -1? No, because again, my distance can be 0. My distance can be a positive number. None of those values are going to be less than -1, right? So this is actually the one where there is no solution, which means it's an empty set. Sometimes they like to write empty sets like this. And that also means if you had a number line, it will be blank because you can't shade any part of it since it's an empty set. I am actually not sure what MyMathLab wants on this. Does it just want you to pick there's no solution and a blank line, or does it give you one of these symbols? So I'm just including everything in there. Questions? Okay. So out of these 4 different problems, you should expect to see at a minimum 2 of them. I'm not sure if I will have more than them, but you definitely want to try and look through all 4 of these through your homework. If you have any questions, let me know. And I will actually send you the solutions to these applications so you can see how it worked out. I don't want to keep you any longer than what I have. Okay. All right, guys, so at this point,